attack is actually saying like this. If an attacker can output phi n given n, then this attacker breaks RSA. So you can see that here, if there is an attacker that can output phi n, remember what is phi n? Phi n is the number of integers between 1 to n minus 1 in which the GCD of that number and n is equal to 1. That's phi n. It's Euler quotient function. Okay? If someone can compute phi n given n, then this person can break RSA. That's why to find phi n actually is a hard problem too. So the proof for this one can be given like this. So this is the proof, which is a bit complicated. So what happens is this. You see that the one that's given is basically n. And we know n is p times q. Of course we don't know p and q. But we know n is p times q. Okay? So now suppose that given n, there is a person who can compute phi n. So that means the attacker outputs phi n somehow. You ask me how, we don't know, because we assume. Suppose the attacker can output this one. We know phi n is p minus 1 times p minus 1. Okay? Alright, so now I will do a simple substitution. So you can see that simple substitution like this. So that means phi n is p minus 1 times q minus 1. Okay? This is equal to p times q minus p minus q plus 1. That is phi n. Okay? And then we are given n is equal to p times q. So here I will rewrite this. Q is n over p. Yeah? This is what I call equation 1. Okay? So I will substitute this to equation 2. This is my equation 2. I will substitute equation 1 to equation 2. This will give me p times q. Q is n over p. That means it's n minus p minus q is n over p plus 1. This is phi n. Okay? And then what I will do is, I will move everything to the left. To the left. So I can get p. So p I move to the left. And then plus phi n minus n, yes, plus n over p minus 1 equal 0, yes? Okay? And then from here, I can multiply the whole equation by p, so that looks neater, right? So it looks neater. So what it means is, I'll get p squared plus p phi n minus p n plus n minus p equals 0. Yep. Okay, so now you can see that this is p squared, this is p, this is p, so I can take p out, phi n minus n minus 1 plus n equals 0. Yes? So you can see that from this equation, I know phi n, yeah, because the attacker can compute phi n. I know n, and I know n. That means I can solve this equation. Okay, how can I solve this equation? I think in high school you study this. Right, so this is usually, this is like this, ap squared plus bp plus c equals to 0, yes? And then I can compute p, there are two p's, because this is squared, that means there are two roots, right? There are two roots. So what we can do is P, I call P1 and P2, for example. There are two roots, right? So this is equal to minus P okay? Alright, so that's that formula, right? You remember this one? Yes? Yes? You study this one? Of course, right? You don't study this one, you need to let me know who your tuition is. So, alright, so if you have like this, then what you do is, now you can compute T1 and T2 will be equal to, this is my B, so that means minus phi n minus n minus 1 plus minus phi n minus n minus 1 square minus 4 times 1 times c, that means c is n, divided by 2. So you will get two results from here. If you ask me why there are two results, because one result is T, another result is Q. So that means if there is an attacker can output phi n given n, that means that attacker can actually factorize P and Q. If this attacker can factorize P and Q, what will happen? According to the previous one, that attacker will be able to break RSA. That's why if there is an attacker can output phi n from n, this attacker can break RSA. This is actually the proof. Okay? Any questions? Did you study this one before? Yes, right? Yes, right? Yeah, definitely you studied. For sure. 100%. 100%. This is the beauty of mathematics. After a long time you study, eventually you will see that